Hi everyone! We're introducing caching. Caching is a feature that we added to Hamilton version 179 and it should make your life easier. What is caching? Broadly, it means execute a node only once. Instead of executing it again, what we would do is store results on the first execution, and on later executions, we would retrieve that result and use it. That allows you to save time when executing complex workflows, but also save resources because you don't have to spend the GPU time, the CPU time, the API credits to compute the operation a second time. So for this video, we'll go through the caching notebook tutorial. As you see from the table of contents, there's quite a lot to unpack. I highly suggest you go through it yourself. It's available on GitHub and on Google Colab. And for now, we'll only cover the first two sections to introduce the basics. I already executed the first three cells, which are there to import the notebook extension. There's an entire video on that and tutorial. And I'm also getting the logger for visibility and deleting the previously stored result. This is to ensure that everything runs as expected. So quick reminder about Hamilton. Hamilton allows you to define a data flow. It is a directed acyclic graph based on how you write your functions. So process data has a first argument named raw data. Raw data is another function, and both are annotated as pandas data frame. This means raw data here in our visualization is a data frame, and it points to processed data, which is also a data frame, as annotated here. Cutoff date is a dependency, so it's upstream of processed data, but it's not associated with any code, so it's called an input, as seen here in the visualization again. So caching would mean if we were to execute raw data and processed data once, we shouldn't have to execute them a second time. Here is just a few lines of code to create the driver. The driver takes in the basic module. The basics module is here. We defined it. It's the entire code that's present in this cell. And then we will request the node processed data with the cutoff date of the 1st of September. Here, the logger tells us that we executed the node raw data, we executed the node processed data, and this is the result we have for processed data. With caching comes a new visualization that's available on the driver, cache attribute, and using the viewRun method. And here we see that we requested processed data and that nothing was retrieved. If we were to execute the same code again, it's exactly the same call. We request processed data and we pass the input of the 1st of September. Now we see that we retrieved the result and it was a hit, making it meaning it's a success. And here we also retrieved the result for processed data. This is displayed in the visualization. We have the from cache outline that's present, and it means that we didn't actually execute any of these nodes. We simply read the values. So how does that work? Taking a step back, we have to ask ourselves, what does it mean to define like the execution context? Why did we produce a value or another? For raw data, it is defined via the function raw data that I will go back here. So raw data is defined by its function, and it has no input. It has no upstream dependencies, as seen here in the function signature. So if we have the same code for raw data, we would expect the same result. For processed data, again, it is defined by its code. So the lines of Python code that are present here. And then it's also dependent on the values that it receives. So the value of raw data and the value of cutoff date. If the code is the same and these values are the same, then we should be able to retrieve the result. And this is what is expressed here in the cache key. For the cache key of raw data here, we have a code version, so the version of the Python code, and we have no dependencies data versions because it doesn't depend on anything else. As we see, there's no upstream nodes. On the other hand, for process data, we have a code version, and we have versions for the data of cutoff date and for the version of the data of raw data. And I want to emphasize that raw data has a data version that's here, and it has a code version, which are different. Because if you are to execute the same node, it could have the same code, but produce different values. This is a lot to take in at once, but just keep that idea in mind as we go through the notebook. We care about two things: the code version of the node and the data version of the data that comes in. So here we have the same like module definition as before. We call it adding node module this time, but we added a node called amount per country. And we see it's the same visualization. It has a new node. And now that we're building the driver with this new module, we will execute it and again pass in the same cutoff date. One thing I forgot to mention, to enable the cache, all you have to do is add the statement with cache, and it will behave as described so far. So if I execute this node, we see that raw data is a hit. We were able to get the result. Process data is a hit, and amount per country was executed. That matches our expectation, right? Because we have the same code as before for raw data, so we can retrieve it. We have the same code as before for process data, and the same values for raw data and cutoff date. Remember, we pass in the same input for cutoff date and raw data, like nothing changed on this end. However, amount per country is a new node, so obviously there's no cached result for it. And now we see that it was executed. If I am to execute the same cell again, we see that this time it's a hit because obviously it receives the same inputs data and it has the same code. Okay, so what if we were to change the input? Instead of passing the 1st of September, we will pass the 11th of September. It is still the same module, adding node module, but we simply change the date. Now we see that a few nodes were recomputed. Why? Raw data has the same code, and its dependencies haven't changed, so we can read it from cache. For process data, however, one of its input has changed. So despite process data having the same code, we must recompute it because we don't know what would be the result with this new cutoff date. Because we received a new result, we also have to execute amount per country. This is illustrated later on. And then, well, actually, what I mean by that is if you look here, this is the result of amount per country. We have values for Canada and values for USA. But this time, we only have values for USA. This is because the cutoff date changed the result of process data, and so amount per country also have different results. If I'm to execute this same data flow again, but with the cutoff date 0905, what are we expecting? Think about it for a second. Actually, I would say we don't know because we will need to execute process data, and then we might be able to retrieve amount per country or not. See, we were actually able to retrieve amount per country. Why is that? It's because the caching works by walking node by node. We started with raw data, we were able to retrieve it. We moved to process data, same code, okay. Now we look at the data. The data for raw data is the same. The data for cutoff date is new. So we must execute this node. But when we inspect the result of process data and we go to the next node, amount per country has the same code, and the input process data is the same as one that we've seen previously. And this is highlighted here when we added the node. This is a result from a previous execution, and this is the result from the current execution. We'll see that if we put the cutoff date 2024-0901, or we put the cutoff date 2024-0905, the results are the same. So that's why we were able to retrieve amount per country. This is very powerful because it means that if we add like a lot of nodes downstream, let's say you're training a model, you're doing analytics, blah, 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 you won't have to recompute them because the algorithm is smart enough to detect that the changes only affect from cutoff date to process data, and then afterwards it's a known path, for example. So what about changing code? Here we have the same data flow as before, but we changed this value. We changed a simple float from a value to another. This is the conversion rate from Canadian dollar to USD. Actually, if we look at the data flow, I add the display flag, we can see that it has the same shape as before. We create a new driver, we pass the cutoff date of the 1st of September. What do we expect? In this case, we change the code for process data. So we must execute process data, even though cutoff date changed. And so we execute process data, we evaluate its value, and because it's a value we've never seen before, we have to execute amount per country too. If we look at the values that we have with the new currency, the exchange rate, the values are different from here. The Canada value is different. Now, what if this is the line that we changed previously, 71, but now we're adding 2 more lines to change currency from Brazil and from Mexico into USD. As we see in the data here, we have no entries for Brazil or Mexico. What are we expecting? Taking a second to think about it. We have the same cutoff date as before. Well, this time we had to execute process data, and we did, but we were able to retrieve amount per country. Why is that? Because even though we added code, this code didn't affect the results. Like I mentioned, there are no entries for Brazil or Mexico, so this code change has no effects on downstream nodes. And this is emphasized here where we have the same outputs for the process data node. So this really highlights the 2 key elements of how code and data affects the caching. But there's a slightly trickier case that happens when you're reading external data. I will introduce the concept of idempotency. It sounds complex, but it really is simple, and it is very important to understand this concept because it has an important role in data engineering as a whole, whether you're working with Hamilton or macro orchestration systems like Airflow. You need to be aware of this. So idempotency, there's a great link here that you can look at. It's from the astronomer documentation. Idempotency assumes that if you give the same input to a function, it returns the same outputs. This is obviously a desirable trait, but it's not always possible to achieve. To illustrate that, I have a simple function that returns the current date time. And this is obviously non-idempotent because if I'm executing this function several times, it will return different values. Then another very common use case in data engineering is reading data from a source. Here we have a dataset node that reads from a file path. This file path points to a CSV. We load that CSV and we return a data frame. Now think about it. This node has code, like the 2 lines here that we have. It has this code. And then file path points to somewhere. It's a string. Even though I have the same file path and the same code, this node could produce different values. Because if you were to change the file on your disk from, let's say, a CSV that has 10 records to a CSV that has 100 records, it would be the same file path, the same code, but it would return different data frames. So It's important to think of that when you're using caching because Hamilton cannot know about this automatically. This is the same scenario when you're reading from a database, for example. Yes, you have the same connection to the database, it's the same code to read from the database, but the database might have new records or deleted records. So to illustrate that, we added entries to this data dictionary that we load in raw data. This is to simulate reading from a different file, for example, well, reading from an updated file or an updated database. Now we have entries for Mexico and for Brazil, for instance. Just to show you clearly, it has the same shape as before. Now, what are we expecting? By default, Hamilton will just read the values from cache. We know that raw data should return something different, but Hamilton doesn't know about that because it just sees the same, well, it doesn't have an input here, it just has the code, so it has the same code, it has no dependencies, therefore I can read from cache. But how do you change this behavior? You can change it in two places. At the driver level using the with cache statement, or at the data flow level using the cache decorator. So here in our with cache statement, we have recompute, which receives a list of known names, and we will pass it raw data. This ensures that we read raw data. It will force recompute of raw data, and then process data will be executed because it has the same code, the same cutoff date, but the value from raw data is new. And so process data will have a new output and amount per country will also have a new output. So all the nodes were executed. If I am to rerun that same cell, this time raw data was again executed because we forced recompute, but process data and amount per country were retrieved. With the cache decorator, you can import it from the function modifier subpackage, and you will specify behavior equal recompute for raw data. So now we're building a new driver. Here in with cache, we don't have anything specified. We just have this new module which has the decorator, and we will execute it. As you see, raw data was forced to recompute and process data and amount per country were successfully retrieved. So one important thing to note is that you will need to use with cache or the cache decorator, but with cache will always have precedence over cache. So if you specify a behavior in cache, but a different one in with cache will override it. Also note that adding the cache decorator alone does not enable caching. It is the with cache statement on the builder that does. So this is it for the first part of the caching tutorial. We invite you to investigate further. There are a lot of things that are covered. For example, how do you deal with loading and storing data? How do you cache using specific formats? So you could cache results in Parquet or in JSON. And there are other special behavior that you can specify in the with cache statement. I hope that gets you started with caching. And if you have any question, feel free to join us on the Slack community. And we're very eager to learn about your experience and help you solve your issues. Thank you.